join you from down under. So I'm going to be talking about 10 years at EucFACE. We're coming in for our 10-year anniversary of CO2 fumigation later this year. So obviously you can do a lot of science in 10 years. All I can do in this talk is give you a couple of highlights. Oops, sorry, there we go. This is what the site looked like before the FACE experiment. It's a natural Eucalyptus tereticornis woodland. The traditional owners of this land are the Darug people. The English settlers arrived in the late 1700s, but this woodland was never cleared as far as we know. It was probably used as a commons. The agricultural college started 130 years ago, and this woodland has been undisturbed as far as we know during the tenure of the college. So it is a native forest. As you can see, it's got a really low leaf area index. And one of the reasons for that is that the soils are really quite poor, but not exceptionally so. So these data just show you where EucFACE sits globally for soil available phosphorus and for the leaf phosphorus to leaf nitrogen ratios. So my colleague Mingkai Zhang pulled together some global data sets, and you can see the red lines and red dots showing you where EucFACE sits in the global scheme of things for phosphorus availability. We do know that phosphorus availability is limiting for growth. There was a phosphorus fertilisation experiment carried out about 10 years ago now by Christine Creese and David Ellsworth, which showed that there was a strong response of tree basal area increments to phosphorus fertilisation. So at the outset of the experiment, we ran a model into comparison to see what models predicted for the CO2 response in this experiment. And so what you see here is the range of predicted responses across 7 different terrestrial ecosystem models. The 2 in green were the 2 that were phosphorus enabled. And so you can see at that point in time, there was a prediction that phosphorus availability would likely limit the CO2 response. And this was a really useful thing to do at the outset of the experiment, because it enabled us to really lay out what the alternative competing hypotheses for the experiment were, and to design our measurements to make sure that these different hypotheses were addressed. So one of the major findings from the first 4 years of the experiment was that there was no increase in above ground growth from elevated CO2. So we were able to put together a full carbon balance for the experiment. Our estimates were that the gross primary productivity of the forest had increased by about 11 to 12%. But most of that additional carbon was coming straight back out again from soil respiration. There were also increases in stem respiration and in the understory biomass. So there really wasn't a response of above ground growth. Our interpretation was that that was a phosphorus limitation, and we have been gradually assembling the phosphorus budget to go alongside the carbon budget. And that phosphorus budget really demonstrates that phosphorus limitation and the tight phosphorus cycle has constrained the response to CO2. So what I'm showing you here is the soil part of that budget. So you can see our estimates of total soil phosphorus are quite low. And our estimates of microbial phosphorus are quite high. So there's a lot of the total phosphorus of the system in the microbes, more than there is in the plants, considerably more than there is in the plants. The net mineralization rates are low, and they're pretty much matched by the plant phosphorus uptake. So we can tell that there is quite a tight phosphorus cycle. The plants are also retranslocating a lot of phosphorus before litter is shed, which is another sign of this tight phosphorus cycle. And the competition between the plants and the microbes is another factor to take into account that limits the capacity of the plants to respond. So these data are super useful to help us constrain models. It's really a pretty unique data set so far. We're in the middle of another model into comparison. There are many more phosphorus-enabled models for us to look at now. And so you can see here, this is the current model into comparison. We've now got 8 models as opposed to 2, and there's a bit more of a range of predicted CO2 effect by the phosphorus-enabled models, because the range of models is now exploring more assumptions about how phosphorus and CO2 interact. Like I said, this data set is really quite unique to help us constrain models. What we're seeing so far is that none of the models are really capturing the observations. So what you can see here is the CO2 effect on the change in biomass, the observations compared to the range of models that we have. There are only 2 models that look like they're capturing the observations. We know one of them is doing it for the wrong reasons. And the other one is our in-house model that we've bodged to match the observations. So there's really very useful data set that's been assembled here, which can provide us with a lot of insight into how to capture phosphorus and CO2 interactions in models. We would like to be able to confirm completely that it is the phosphorus cycle that's limiting the CO2 response. So there's a proposal that's currently being considered by the university executive to fertilise 2 of the rings with phosphorus in spring, September, later this year, which will enable us to look more explicitly at the CO2 by phosphorus interaction. But in the meantime, things have been happening at EucFACE. So the last 4 years in particular have been a series of extremes. The data that you've seen have been from the first 4 years of the experiment. We then went into a really extreme drought, the worst one we've had for 60 years, followed by 2 years of floods. So the trees have had really quite a lot of disturbance. Starting with an insect infestation in 2015, followed by this really severe drought, followed by the floods, which have also actually had quite an impact on the canopy. So some of the trees really have not liked being waterlogged. And there's also been an invasion of lianas, which we're studying together with colleagues at the University of Nottingham. So this is really a story of climate change in action, because these extremes that we're experiencing at EucFACE are very much climate related. And so we're still trying to pick apart how the CO2 has interacted with this disturbance. But I just want to show you a couple of highlights from the more recent data. So one of the emergent responses is that there is more of a difference now in above ground productivity. So what you can see here is that in the first 4 years, there was really no impact on above ground litter fall. But in 2017 to 2020 period, there's actually been an increase in above ground litter fall of the order of 19%. So we are seeing some CO2 effects starting to emerge, which seem to be reducing the impact of the disturbance. So here's another little fascinating snippet to do with a reproductive effort. So these trees don't flower every year. What you can see here is that there was a flowering event in 2013, and then really we did not see any flowering at all until the peak of the drought in 2019. So when the soil moisture was at its very lowest, the trees went for a massive flowering effort, which seems to be a stress response. So they respond to extreme drought by using up carbon reserves to get reproductive, to get seeds into the soil, basically. And there was a strong CO2 response as well. So the CO2, the elevated CO2 trees appeared to have more reserves available for flowering. So key points, what we're finding so far, there has been a real constraint on the CO2 response by the phosphorus availability, particularly under good conditions. The phase experiments provide really unique opportunities to constrain terrestrial ecosystem models, particularly if model data synthesis proceeds in tandem with the experiment. And then the third point is that the impacts of disturbance seem to be reduced in elevated CO2. And this is one of the things that can emerge when you run a long-term experiment. It allows you to see what happens when you experience these really unusual extreme conditions. So I will just finish there with a thank you slide to, again, the very many people who've been involved in this. The core team behind the graphs that you've seen, a lot of people who've put data together, lots of modelers involved, and some very excellent technical support. And this one, this is what the site looks like now. So there's been quite some changes over the decade of the experiment. Thanks.